Welcome to the second part of our tutorial on Simulink. Now let's go ahead and look at the first differential equation we'll be solving graphically with a Simulink. dy over dt plus 2y equals to ut minus 1, where y of 0 equals to 0. And since we are solving it graphically, we'll choose the range for t from 0 to 5. Let's rewrite the equation in the form of dy dt equals to negative 2y plus ut minus 1. And we also notice that ut minus 1 is a unit step function turned on at 0 and turned off at 1. So we can model it with a pulse generator block in the Simulink. Let's go ahead and model our equation in Simulink. We will take the pulse generator block and set the following parameters. Amplitude 1, period 5 seconds, pulse width 20%. From math equation subcategory, we will choose subtract block. And from the same subcategory, we choose gain block and change its gain to 2. From continuous subcategory, we choose integrator, and from sinks, the scope. Now we connect our parts. Be sure to connect with a black solid line. The labels on the wire are inserted by double-clicking on the lines and typing in the text. Now let's go to Simulation, Configuration Parameters, and change stop time to 5 seconds. And variable step to fixed step with a fundamental sample time of 0.001 seconds. Now we're ready to go, but before we do so, let's check our initial condition of y equals to 0. Our integration block outputs y, therefore we'll click on it and make sure our initial condition is 0. Let's run the simulation and by double-clicking on the scope block, get our graphical solution to the differential equation. We can adjust our axis by using binoculars. Now let's take a look at the second differential equation, and it's d squared y over dt squared plus 3 dy dt plus 2y equals to cosine 2t, with initial conditions of y0 equals to 0 and dy dt equals to 1. And we'll be solving this equation graphically on the interval from 0 to 10 seconds. Let's rewrite our equation in the form d squared y over dt squared equals to negative 3 dy dt minus 2y plus cosine 2t, and construct block diagram in Simulink. From sources subcategory, we choose sine wave block. and change its parameters by double-clicking on it to the following. Our frequency is 2 radians per second and our phase is pi divided by 2 because according to our equation we need a cosine, not sine. From math operations, let's get subtract block and change its list of signs to plus, minus, minus. From the same subcategory, we choose two gain blocks and adjust their gains to 2 and 3. Let's put two integrators from a continuous library and the scope block from the sinks. Now we connect the blocks, keeping in mind that the second derivative comes out from the subtract block, the first derivative from the first integrator block, and y function from the second integrator block. Let's set initial condition of y of 0 equals to 0. Since y comes out of the second integrator block, we double click on it and set initial condition to 0. In our case, it's already 0. dy dt equals to 1, so we double click on the first integrator and set initial condition to 1. Now let's run the simulation. After double-clicking on the scope block and adjusting y-axis with binoculars, we can see a graphical solution to the differential equation. This concludes our tutorial. Thank you for your attention.